In part 2 of our lesson on trigonometric equations, you will learn how to solve by factoring. In this first example, we have to solve on the interval 0 to 2 pi, so of course that tells us we're in radians. Our equation is 2 cosine squared of x is equal to radical 3 cosine of x. Now, you might be tempted to divide both sides by cosine of x, but you absolutely positively cannot do that, the same way you could not do that back in your algebra class. You cannot get rid of a variable that way. You had to gather the terms and then factor to get all the solutions. So what we do have to do here is pull everything on one side, so we get 2 cosine squared of x minus radical 3 cosine of x is equal to 0. Next, we're going to factor. We see we have a cosine of x in common, so we pull out the cosine of x, and we have left 2 cosine of x minus radical 3 equals 0. Next, we will use the zero product property, and we'll say that cosine of x is equal to 0, or 2 cosine of x minus radical 3 is equal to 0. Here, we have to solve for the cosine of x, so we have 2 cosine of x is equal to radical 3, or cosine of x is equal to radical 3 over 2. So now we have these two equations to solve. Cosine of x is equal to 0, cosine of x is equal to radical 3 over 2. So let's take them one at a time. Let's draw a picture for this one. We have cosine of x has to equal 0. Well, we know that the cosine is 0 here and here. Since we're in radians, this is going to be at pi over 2, and this one will be at 3 pi over 2. So from this equation, we're going to get two solutions. X is equal to pi over 2 or 3 pi over 2. Next, we have to solve cosine of x is equal to radical 3 over 2, and we know that cosine is positive, means that our angle could be in quadrant 1 or quadrant 4. Using our special angle chart, we know that the reference angle has to be pi over 6. So we'll put that reference angle here, and of course that will be pi over 6. And if we put the reference angle here, we start at 2 pi, back up by pi over 6, and we would be at 11 pi over 6. So then from this piece of the equation, we're going to get x is equal to pi over 6 or 11 pi over 6. So this equation ended up having 4 different solutions. Next, we have to solve on the interval 0 to 360 degrees, so we know we're going to be in degrees. Our equation is radical 2 sine of theta times tangent theta is equal to negative tangent of theta. So, as we've discovered, we cannot divide both sides by tangent. That's what we cannot do. We know that we have to gather up everything on one side. So we've got radical 2 sine theta tangent theta we will bring this minus tangent theta over to become a plus tangent theta on the left-hand side and equals 0 on the right-hand side. Remember, this is an equation, so it has to have something on the left-hand side, an equal sign, and something on the right-hand side. Now we are ready to factor, so we can factor out a tangent theta, and we have left radical 2 sine of theta plus 1 equals 0. We can apply the zero product property to say that tangent of theta has to equal 0, or radical 2 sine of theta plus 1 has to equal 0. This one has the trig function isolated already, so let's work on this one. We would subtract 1 from both sides, and now we have radical 2 sine theta is equal to -1. Next, we would divide by radical 2, so now we have sine of theta is equal to -1 over radical 2. To make this more recognizable, let's rationalize it. So now we have sine of theta is equal to negative radical 2 over 2. Let's go ahead and make this picture. We know if sine of theta is negative, then that means we have to be in quadrants 3 and 4. We go to our special angle chart, and we see that theta r is going to equal 45 degrees. So we have to put theta r here, and we know we would be starting at 180, adding 45, and that would get us to 225 degrees. We have to put theta r here in quadrant 4. We would be starting at 360 degrees, back up by 45 degrees, which would put us at 315 degrees. So from this piece of the equation, we are going to get that theta is equal to 225 degrees or 315 degrees. Now over here, the other part of the equation, we have that tangent has to equal 0. So if we look at that picture, we know that tangent is y over x, so tangent's going to be 0 when the y value is 0, and that happens here at 0 degrees and over here at 180 degrees. So from this piece of the equation, we get that theta is 0 or 180. So once again, this equation here has 4 solutions. In this example, we have to solve on the interval 0 to 2 pi, and of course this tells us that our answers will be radian angles. The equation we have to solve is 4 cotangent of x equals 3 cosecant x cotangent x. We know that we have to gather up the terms on one side, so we're going to have 4 cotangent of x minus 3 cosecant x cotangent of x is equal to 0. We see that we can factor out a cotangent x, and we would have left 4 minus 3 cosecant x equals 0. Using the zero product property, we have that cotangent of x will have to equal 0, or 4 minus 3 cosecant x will have to equal 0. This one's already solved for the trig function. This one, we need to isolate the trig function. Subtracting 4 from both sides, we get negative 3 cosecant x is equal to negative 4. Dividing both sides by negative 3, we get cosecant x is equal to positive 4/3. Negative divided by negative is positive. Because the cosecant is positive, we know that that means we're going to be in quadrants 1 and 2. We will want to change this into sine of x. So if the cosecant is 4/3, then that means sine of x will have to be 3/4. Looking at our special angle chart, we see that this is not one of the values that we have, so we're going to be using our calculators. If sine of x is equal to 3/4, we know that means we can rewrite that as x equals sine inverse of 3/4. So now we need our calculators. First, we see we need to be in radian mode, so we hit the DRG button, cursor under the radian, and hit enter. Now we have to find the sine inverse, so we'll do second sine inverse of 3 divided by 4, close the parenthesis, hit enter, and rounding to the hundredths place, we see we're going to get 0.85. Now let's get that in our picture here. We know that this will be our reference angle going here, which means that this angle would be 0.85. We also have to get it into quadrant 2, so we put it here. And to find the quadrant 2 angle, we're going to do 3.14. Remember, this is pi, and we can use 3.14 since we're rounding to the hundredths place. We have to subtract away our reference angle, which we just said is 0.85. Input that on our calculators, and we see we get 2.29. Now you always want to make sure that your answers are making sense. If we look at the unit circle and think of the approximate angle values, we know this is 0. We know here at pi over 2, if we approximated that, it would be 1.57. Here at pi, we know that's 3.14. So the answers that we're getting are making sense with the quadrants that they have to belong in. So for this part of the equation, we are getting that x is equal to 0.85 or 2.29. We still have to solve this part of the equation over here. We can draw a picture. We know that cotangent of x would be 0 whenever the cosine is 0. Cotangent is cosine over sine, or x over y, and I mean x over y here, not this x. X over y here on the unit circle. So we know that cotangent will be 0 here at pi over 2 and at 3 pi over 2 whenever the cosine is 0. So this one gives us x is equal to pi over 2 or 3 pi over 2. So we were able to give exact answers for this one. What that means then is this equation that we started off with has 4 possible solutions.